Question 5 for tutorial 5. In this question, you will be required to build a variant of the solution to the Hauer-Hanoi problem presented in class. So we have to define a disk move to be a pair of two numbers, the source pole and the destination pole. So for example, a pair of numbers in the tuple 1, 3 indicates the movement of a disk from the first pole to the third. So the function Hanoi will take in 4 arguments: the number of disks, the source pole, the destination pole, and the auxiliary pole. So it returns a tuple of disk moves that if executed in that sequence, will move all the disks from the source pole to the destination pole. Okay, so let's firstly look at what been taught in the lecture. Okay, so this is very similar to the function in the lecture notes. So instead of calling print move function here, I'm just simply printing the source and destination here. Okay, so what this thing does is, for the base case, if the size is 0, basically there's no disk on the source pole, we just return something, right? So we can return true here, but this will print nothing onto the screen. Else case is achieved by 3 steps. The first step is a recursive call to move the disks except for the last one from the source to the auxiliary pole. So this is achieved by calling the Hanoi function with size -1 and swapping auxiliary and destination. Okay, and the second step is just to move the last disk from the source to destination. So here we just print this onto the screen. Okay, and finally we are moving the disks from the auxiliary pole to the destination, and this is again achieved by calling the Hanoi recursively. Okay, after we understand how this is implemented, we can see the output. If we call Hanoi 3 and 1, 2, 3, we will get something like this. So we can actually compare the screen printout with what is the design output on the left, right? So this output are actually very similar. So this, so instead of having a tuple on the left, on the right we actually have a pair of numbers printed in a single line. Instead of having all these tuples collected into a large tuple, and here we are just separating these pairs into different lines, right? So they're actually very similar. The sequence is exactly the same as this one on the left. So if you have understood this and the Hanoi function in the lecture notes, we can actually easily modify this into the required function. Okay? So instead of printing everything to the screen, we just keep collecting all these pairs into a tuple. Okay, so basically to do that, the base case, instead of returning true, we have to return an empty tuple because we are actually collecting these results, right? So for the else case, the first we can actually initialize the results rest variable to be a set of moves of the recursive call. So the recursive call of this Hanoi will actually return a tuple because the base case is a tuple. And this is the initialization of the results. And again, we have to move the last disk from source to destination. And this move is actually a single element in a tuple, and for this we just have to append this to the result. Okay, and similarly for the final step, to move the disk from the auxiliary to the destination, we again collect this set of movements to the result, and of course in the end we have to return the result. Okay, and this is actually the solution to this question.